this is your homework 5, which is some naming practice. So the directions for this homework, first we're going to have to determine if we are ionic or covalent / molecular. Those words more or less mean the same thing. And then we need to highlight the polyatomic ions, circle the cations that can have more than one charge. So in this case, I'm talking about the transition metals. And then we're going to have to write either the name or the formula based on what the blanks are. So some tools that you will need for this, you'll definitely need a table of elements, so you can use your mint sheet with the polyatomic ions on the back. And what I recommend you do with these, anytime you get a new table of elements, you should label the charges. That way, whenever we're looking at it later, we can see those real quick. So +1, +2, +3, and then we have our anions, -3, -2, -1. Okay, then a couple other things that you can do here. We're looking to figure out if something is ionic or covalent, so it will be helpful to know what our metalloids and what our nonmetals are. So here are my metalloids in yellow. And remember, everything that is to the right of that staircase plus hydrogen. So don't forget hydrogen over here by itself. These guys are going to be all of my nonmetals. So once we have our table of elements all labeled, this will be our tool that we will use during our homework to name. Next thing that you can do, I've got some flashcards here. So I've got a flashcard that talks about ionic and a flashcard that talks about molecular, aka covalent. And then I've got another flashcard that has the transition metals that have only one charge. So I have these printouts for you, and you can take a copy home and make them into note cards that you can use to help you study. So first, let's do step 1, which is determine if it is ionic or molecular. So for ionic, I'm looking for a metal and a nonmetal, or it has a polyatomic ion. And for covalent, I'm generally looking for 2 nonmetals. So let's start. This one, I've got Na and I've got CO3. So one of our other steps is to highlight all of our polyatomic ions. So I know that this is polyatomic because I can count their sodium, one type of atom, carbon, another type of atom, and oxygen, a third type of atom. So the fact that I have 3 different atoms in this compound, different kinds of atoms, that alerts me to the fact that there's probably a polyatomic ion in there. So in this case, it's the CO3. All right, so we have a polyatomic ion. Therefore, we know that this must be ionic. The next example, I have Dinitrogen Trioxide. So this one's going to be covalent, and I know that for 2 reasons. Number 1, nitrogen and oxygen are both nonmetals. Number 2, I'm using the prefixes, and those prefixes are only going to apply to covalent compounds. I have P2O5, so I don't have the name, but I have phosphorus and oxygen. So if we look on here, phosphorus and oxygen are both nonmetals. Therefore, this must be a covalent compound. Okay, nitrogen is a nonmetal. So we have another covalent compound here. Next one, I've got CaSO4. So let's count. Calcium, sulfur, oxygen. 3 different kinds of atoms means that this must contain a polyatomic ion. In this case, it's SO4. So because this has a polyatomic ion, it is ionic. Next one, lithium acetate. So lithium is a metal, and acetate, you're not going to find acetate anywhere on this table of elements. It ends with 8. So that's a big hint that it's going to be a polyatomic ion. So I can find acetate on there. There it is. It's polyatomic ion. So I need to highlight my polyatomic ions. Okay, next I have SO4. So FeSO4 is 3 different kinds of atoms, so that means I've got a polyatomic. Silver phosphate. Phosphate ends with ATE, so it's polyatomic. So for these next 3, I know they're all going to be ionic because they all have polyatomic ions. Okay, I have SiO2 coming up next. So SiO2, here's Si, and then we have oxygen. So in this case we have a metalloid and a nonmetal, so this is going to be covalent. Next I have titanium, which is a metal, 4 nitrate. So I have a metal, and this ends with 8, so this means it is a polyatomic ion. So this guy must be ionic. The other direction was to circle the cations that can have more than 1 charge. So if we go back, titanium obviously, because it's got Roman numerals with it. I'm basically looking for anything that's a transition metal. So silver technically is a transition metal. Iron is a transition metal. I've got lithium, calcium, sodium. Those are all not transition metals. All right, so let's look at naming these. So this is ionic, which means that I want to apply my ionic rules. So I got to make sure my compound is neutral, and I have to use Romans whenever I'm uncertain of the charge and change the anion to end with "ide." So in this case, Na is sodium. And then CO3 is a polyatomic ion, so I got to look that one up. So I find CO3, and that is carbonate. So in the case of a polyatomic ion, you just got to write the name. So that's just plain old sodium carbonate. Dinitrogen trioxide. This one's covalent, so I'm switching over to my prefixes. So dinitrogen means 2 nitrogens. Trioxide. Oxide used to be oxygen before we changed the ending, so this is trioxygen, so that makes N2O3. Over here, I've got phosphorus and oxygen. So again, oxygen, we got to change to oxide, and I got to use my prefixes. So I've got diphosphorus. So that takes care of that guy. And then I've got penta 5 oxide, pentaoxide. This one is also covalent, but whenever we see a pure element just by itself, that means that that element is going to be, could be one of the polyatomic ions. So there's 7 polyatomic ions. So this is how I remember. Have no fear of ice cold beer. So those 7 are my diatomics, or you can make it 7 at 7. So what that means is that if I have just plain old nitrogen or just plain old oxygen and it's not with anything, it's going to be diatomic. So this should be N2. All right, the next one is ionic, so we got to mentally switch back over to our ionic rules. So Ca is calcium, and SO4 is going to be sulfate. So this is just calcium sulfate. The next one is lithium acetate. So this time, since we're going from a name to a formula, we got to make sure our charges are balanced. So lithium has a +1 charge, and acetate has a -1 charge. So whenever I crisscross the charges, I have lithium +1 and acetate, polyatomic ion, got to look up the formula. So whenever I crisscross the charges, they're just going to be Li1, acetate 1, so it's just lithium acetate. Next one, FeFSO4. So for this one, I'm going to have to be careful because I've got a transition metal. So that means I'm going to have to use Roman numerals. So let's start with what we know. Fe is iron. Okay. I got to figure out the charge of iron next. So this is how we got to do it. I've got my anion is going to be SO4, which is sulfate. So the charge here is -2. So sulfate has a -2 charge, which means I need to have a +2 charge to balance that out. There's only one iron. Therefore, that one iron must have a charge of +2. So this would be iron 2 sulfate. Okay. Silver phosphate. So silver is in the middle with the rest of the transition metals, but it's not a transition metal. So silver is not a transition metal because it has just one charge. So silver is +1. That's why we don't have Romans here. If you write Romans, I won't mark you wrong, but just be aware that silver is +1. So if you see it in your textbook, it might not have the Roman numeral. Same thing for cadmium and zinc, except those are +2. So I've got silver with a +1 charge, and then I've got phosphate, which is a polyatomic ion with a -3 charge. So whenever I crisscross my charges, so this 1 is going to go after the PO4, and this 3 is going to go down here. So it's just Ag3PO4. SiO2, this is covalent, so we're switching over to our molecular rules, which means prefixes. So I have 1 silicon. You never start with mono though, so I'm just going to write silicon. And then oxygen becomes oxide, and there's 2 of them, so that is dioxide. Here's another one that is ionic, and this has got everything going on. It's got a transition metal, it's ionic, it's got a Roman numeral, it's got a polyatomic ion. So the reason I had you circle and highlight is so that whenever you get to these, that doesn't sneak up on you and you know what to do. So titanium, in this case, has a +4 charge. It tells you with Roman numerals. Nitrate is a polyatomic ion with a charge of -1. So I know right away, since this is -1 and this is +4, I need to have 4 of these guys. So I get a negative charge of -4. So I've got titanium, nitrate, and I need 4 of them. So this is that same kind of switch crossing over. I need 1 of these and 4 of these in order to make the charges balance. The back is more of the same. So first thing we should do is identify these as either ionic or covalent. So I've got gallium and chlorine. So gallium is a metal, Cl is a nonmetal, making this ionic. Copper 1 phosphate. I've encountered a polyatomic ion, which means this must be ionic. I also have a metal that can have more than 1 possible charge, and that's copper 1. Here I've got cobalt and bromine, so that's a metal and a nonmetal. And this one is a transition metal, which means more than 1 possible charge. So because I have a metal and a nonmetal, this is ionic. Next one is potassium acetate. There's a polyatomic ion, so I know that it is ionic. B2H4. So I've got boron and I've got hydrogen. Boron is kind of one of the weird ones. It can form ionic or covalent compounds. In this case, this would be a covalent compound. And I know that because I've got my nonmetals. Disilicon hexabromide. The fact that I have prefixes tells me that it's covalent. I've got Cr, which is chromium, and the polyatomic ion carbonate. So chromium is a transition metal, and I've got a polyatomic ion, therefore this one will be ionic. Iron 2 phosphide. There's a transition metal, iron. Phosphide is a nonmetal. So I know right away that this is ionic. Next, I have LiOH. So OH is a polyatomic ion, which means this is ionic. Gallium oxide. So there's gallium, there's oxide. So gallium oxide has a metal and a nonmetal, making it ionic. Here I've got lead, which can have more than one possible charge. It's a transition metal. And I've got sulfur, which is a nonmetal. So I know that this is ionic because I have a metal and a nonmetal. Aluminum hydroxide. So OH hydroxide is a polyatomic ion, therefore this is ionic. And then my last one, I've got vanadium, which can have more than one possible charge, and oxygen. So because I've got a transition metal and a nonmetal, this is ionic. So now let's look at naming these things. So I know that this first one is ionic. So that means that if I have an uncertain charge, I need to use a Roman. Gallium, I know the charge of it because it's in that same column with aluminum. It's in the +3 column that we labeled. So I know the charge of that, and I got to change the anion to end with "ide." So Ga is going to be gallium, named for France. And Cl would normally be chlorine, but we're going to change the ending to chloride. I don't have to do anything special to indicate this 3. Because if I gave you gallium chloride, you would look up gallium, figure out its charge, +3, and then use that to figure out the formula. So I don't need to indicate that. Copper 1 phosphate. So we've got a polyatomic ion, phosphate. So phosphate has a -3 charge. And then I've got copper 1. So copper has a +1 charge. So I know that whenever I crisscross these things, I've got to have 3 coppers, because 3 times +1 gives me +3. If this guy comes down here, I've got 1 phosphate, which gives me that -3. So in order to charge this to balance, I know that my formula has to be Cu3, and then phosphate is PO4. Next up, I've got cobalt, which is a transition metal. So I got to figure out what its charge is. So bromine, I know the charge of that. It's -1 because it's in this column. So bromine's -1, and there's 2 of them. So the total negative charge is -2, which means my positive charge has to be +2. There's only 1 cobalt, so that cobalt must have a charge of +2. So this is cobalt 2, bromine becomes bromide. Potassium acetate is next. So again, I got to check my charges. So potassium is +1. I know that because it's in the first column. And acetate is a polyatomic ion, so I can look that one up. And the charge in acetate is -1. So whenever I crisscross the charges, I just get 1 and 1. So I'm going to have 1 potassium and 1 acetate. B2H4 is a molecular compound, so that means prefixes. So it's going to be diboron, tetra for 4, hydride. Hydride is different from hydroxide, so please be careful with your language that you are using the correct one. Disilicon hexabromide. So silicon is Si, there's 2 of them. Bromide is Br, and there's 6 of them. Disilicon hexabromide. Here I've got another ionic compound with a transition metal and a polyatomic ion. So first, Cr is chromium, so let's write that. Okay. Now I got to figure out the charge on this guy. So the charge of carbonate, you got to look that up. Charge on carbonate is -2. Now there's 3 carbonates. So each carbonate's -2, that gives me a charge of -6. Therefore, my positive charge must be +6. There's only one chromium, so the charge on that single chromium must be 6. And then I've got CO3, polyatomic ion. It means just write it out. Iron 2, phosphide. So this tells me the charge on the iron is +2. Phosphide, if we take off the IDE, used to be phosphorus. So we can look on our table of elements. Phosphorus has a charge of -3. So whenever I crisscross these, I got to have 2 phosphoruses and 3 irons. Next up, I have LiOH. Li is just lithium. I don't need a Roman numeral because I can look at the table of elements and tell you the charge is +1. So I don't need a Roman. OH is just hydroxide. And that's a polyatomic ion. I just looked that up on the polyatomic ion sheet. Next I have gallium oxide. So again, I always got to worry about charges. So gallium has a +3 charge. Oxide used to be oxygen, so that's a -2 charge. So whenever I crisscross these, I'm going to get gallium, Ga2O3. Next up I have lead and sulfur. So Pb is lead, let's write that. This is one of the transition metals, so I don't know the charge of this just from looking on the table of elements. Lead and tin are in that column where we're not sure if they're going to lose 4 or gain 4. So this is going to be also a transition metal. So sulfur, I don't know the charge on lead, but I do know the charge on sulfur is -2. So that means that my total positive charge, since there's only one of them, or my total negative charge is 2, which means my positive charge must be 2. There's only one lead, so the charge in that lead must be 2. We have sulfur. Sulfur is going to become sulfide. Aluminum hydroxide, so got to worry about charges. Aluminum is going to have a +3 charge based on its position on the table of elements, and hydroxide is a polyatomic ion. So whenever I cross these, I know that I need 1 aluminum and I need 3 hydroxides. Last one, we've got the vanadium, and this is going to be a transition metal. So let's start out by just writing out vanadium. Okay, I got to figure out the charge on the vanadium. So oxygen has a -2 charge. There's 2 oxygens. So the total negative charge is -4, which means the charge on vanadium has to be +4, and there's only one of them. So this is vanadium 4, oxygen becomes oxide. So while you're doing this, just remember the basics. For something that is ionic, we're always worried about charges. We're looking for a metal and a nonmetal or a polyatomic ion. And I got to ensure that my charges are neutral. If I'm uncertain of what the charge is, like it could have more than one possible value, I need to use Romans to indicate that. And you change the anions to end with "ide." Now of the transition metals, there are some that you don't need Romans for because they have only one charge. So silver, I don't need a Roman numeral for because silver is always +1. Cadmium and zinc are always +2. So I don't need Roman numerals for those technically. But if you did use them, I would not count them wrong. And for a molecular or covalent compound, we're looking for nonmetals. We're going to use our prefixes, mono, di, tri, etc. And we're going to change the second nonmetal to end with "ide." And you never want to start with mono.